Hi all, it's time to go through the week 5 course notes, and we're on to percentages. So we start out saying the percent really means out of 100. So literally when I say 20%, I am saying 20 per 100. So percentage is hardly a new beast. It's just a different way of saying a fraction where the denominator is 100. Even the percent sign says 100. It's got 100. So it's telling us, and percent is per century. So clearly 20%, 20 on 100, as shown here, it can simplify down. So if that's all a percentage is, then converting between percents and decimals or percents and fractions isn't going to be too hard. But I do like to think of this little drawing down here. And that just shows the percentage is the odd one out. A fraction or a decimal times 100 looks like a percentage. And a percentage divided by 100 becomes a fraction or a decimal. So really they're the same thing, like a half, 0.5 and 50% are all the same thing, but just notice how the size of the number used is 100 times bigger. A half times 100 is 50, 0.5 times 100 is 50. It doesn't mean 50% is 100 times bigger than those other two, it's just 50% involves a divide by 100, so the number has to be 100 times bigger, because 50% means 50 on 100. Okay, so the percentage number looks bigger, but in fact, these are all the same size, a half, 0.5 and 50%, same size. So converting from a fraction or a decimal to a percentage. Well, we said here, we said in the words, or we said in this diagram, to convert from fraction or decimal to percentage, it's purely times 100. So there's a fraction, a quarter, getting times by 100, and 100 is 100 on 1, we know that from fractions. We know we can cancel when it's multiplication. I've got 1 4 there, and there's 25 4s in 100. So I've got myself a 25 on 1, which is just 25%. Now I know I've got calculators in the course, but this is pretty easy stuff to do without the calc. Potentially even quicker at times. From a decimal, well, here it's definitely quicker. What do I do to times 0.25 times 100? Times 100 is just 2 moves bigger. So the decimal moves twice, it becomes 25%. So it's pretty quick stuff to go from fraction or decimal to a percent. Here's another example, 2/5 to a percentage. Well, as we say, times 100 will do it. 100 on 1, and then we've said, look, well here I didn't even cancel. I just went straight forward, but normally I'd say there's 1 5 there, there's 2 5s there, and 2 times 20 is 40. Okay, and because I times by 100, I put a percent symbol there. Great. Page down, to convert 0.4 to percentage, well that's just 2 moves, becomes 40. 5/12 to percentage, well again we put in fraction format, 5 on 12 times 100. Here I've seen that it was 3 4s in 12 and 25 4s in 100, so that gives me 5 25s is 125, 3 1s is 3. That's an okay answer, but this is a better answer. It's just easier to see how big it is when we change it from an improper to mix. How many 3s do I get out of 125? Well, 3s out of 125, I've got 4 in 12 and 1 3 with 2 remainder. There it is, becoming the 41 and 2/3 that you see here. And of course I write percent because I times it by 100. And a 0.026, it's just 2 moves. Don't get put off by weird looking decimals or really small ones or lots of zeros. It's still just 2 moves. The decimal ends up between the 2 and the 6, so it's 2.6%. So that's pretty nice. What about the other direction? From percentage back to either fraction or decimal? Well, it's just the opposite. It's divide by 100. We already said that 25% literally meant 25 per century or 25 per 100. So instantly, really 25% is a fraction, to be honest. And yes, we can simplify it. There's 125 there, there's 4 25s there, so it's a quarter. And to a decimal, well, 25%, the number 25 has a decimal point there. So divide by 100 moves it back 2 moves, which makes it 0.25. So 25% and 0.25 are the same thing. Now, we've got a few more examples, but again, 5% is just 5 on 100. Can simplify down to 1 on 20. 5% with a decimal here, and 2 moves backwards becomes 0.5, and then it becomes 0.05, which is what we've got. So hopefully these examples are making sense. Is there any twists in them? Okay, well this one, 12.5% is 12.5 over 100. Now technically that's not a fraction. It's not incorrect, but fractions are whole numbers on whole numbers. But what's the easiest way to convert 12.5 to a whole number? Well, I could have times it by 2, but one way that's always going to work, no matter what the decimal part is times it by enough tens, as in 10 or 100 or 1,000, to make it a whole number. Here I only need times by 10. If I'm going to times the top by 10, I'd better times the bottom by 10. So the 12.5 becomes 125, and the 100 becomes 1,000. And how do I simplify that? Well, we know we've got our calculators, but there's one 125 in 125, and there's 8 125s there. I could have gone for 5s or 25s, I could have made out a few moves, but I spotted the 125. And again, divide by 100 to convert to a decimal is just 2 moves, becomes 0.125. This one looks a bit nasty. 1/4%. Well, it's still 1/4 over 100, and then because it's not nice having a fraction within a fraction, I like to then write that as 1/4 divided by 100. It's the same thing. And I know that 100 is 101, and I know that in fractions I didn't divide by fractions, I multiplied by its reciprocal. So I'm going to invert and multiply. Leave the first one alone, the divide becomes times, and 101 becomes 1 on 100, and when I multiply the tops it's 1 by 1, multiply the bottoms it's 4 by 100, so it's 1 on 400, so it's a pretty tiny fraction, but 1/4% is going to be. 1/4 divided by 100 is, 1 on 400. And 1/4%, well, I can't move 2 decimals back in a percentage, so firstly I convert the quarter to an actual 0.25. 1/4 and 0.25 are the same thing. If I'm in doubt about that, remember I can always do what is 1 divided by 4. Here's the number 1 getting divided by 4. I can say what falls into 1 goes no times, decimal point. Falls into 10 goes twice with 2 remainder, and falls into 20 goes 5 times. There's a quick proof that 1 divided by 4 was 0.25. And once I've got 0.25, it's easy to bring back those two moves. When I get 0.25 and divided by 100, it becomes 0.0025. And let's just do a little proof here that I'm right. 0.0025. When we looked back at conversions between decimals and fractions, we would have called that 25 over 1, 2, 3, 4 zeros after the 1. 25 on 10,000. And if I divide that by 25, well, I know there's 125 in 25, and there's 425s in a 10,000. So they were the same answer. All good. Never leave a fraction with a decimal as the numerator or the denominator. Absolutely not, because it's not really a fraction. It's got to have whole numbers. So if a question ever says, express this as a fraction, 0.5 on 2 is technically not a fraction. Times it by 10 or times it by 2. If I times the top by 2, I'd get 1. Times the bottom by 2, I'd get 1/4. That's a fraction. Yeah, good. Finding a percentage and percentage change. So this is pretty practical stuff. We get told about certain percentages and percentage changes, like I've got this percentage off in a sale, I made this percent in a deal I made on eBay, percentage change, my bill went up 10%, all these sorts of things. Now we start with an example, and here I'm comparing the hours of sleep I get per day to the number of hours in a day. In other words, I'm asking the question, what percent of the day do I sleep? Now, to make a percent of something, you're talking about some topic, some question, like in this case sleep. What percent is sleep compared to what percent is total? So I'm comparing hours of sleep to total hours in the day. So a percentage is always formed from an amount you're discussing divided by the total amount of whatever it is. So in this case, the hours I'm discussing is 6. I'm getting 6 hours of sleep per day. On the bottom, I'm saying there are 24 hours in a day, so my comparison is 6 on 24. Well, that's a fraction. To convert to percentage, I just times by 100. So the fraction of the night I sleep, or the fraction of the day or the fraction of an entire day I sleep, is 6 on 24, which is the same as 1/4. And 1/4 times 100 is 25. So I could say I sleep 1/4 of the day as a fraction. I sleep 25% of the day as a percentage. So finding percentage change, well, that's only slightly different. It's still comparing an amount to the total, but this time it's not just comparing the thing we're discussing, it's comparing a change. Something changed. And we always calculate a percent by looking at what was the change over what was the original amount of whatever it was. Here I'm saying I had an original amount of 6 hours of sleep, but what I'm going to do is increase to 8 hours sleep. And I want to know, well, what's my increase in sleep? And the formula tells us it's always the change you're discussing over what it used to be. The change here is I'm going from 6 to 8. The change is 2 hours divided by what was the original. Well, the original was 6. So I don't put 2 over the 8. I don't put the change over the new amount of sleep. It's always over the old amount of sleep. Unless there are some times they might request it. We're not going to. Convention is changes over the original. So I've got 2 on 6, which is a third. So I'm saying I changed my sleep, I increased my sleep by a third, but if I want percent, I get a third times 100. And what's a third times 100? 33 and a third, or 33.3 repeater. It's the same thing. So I've increased my sleep by 33 and a third %. Okay, so we've got finding percentage and finding percentage change, very similar things. So here's an example, percentage increase, so that's a percentage change. I'm saying, all I want to know is I want to put the change on top and the original on bottom and times by 100. This population of a town increased from 20,000 to 22,000. Hence the change is 2,000. Big minus small. The original amount was 20,000, so that's what goes on the bottom. And 2,000 on 20,000, if I cancel some zeros, is the same as 2 on 20. It's the same as 1 on 10. And a tenth of 100 is 10. It's 10%. And let's just check that. 10% of 20,000 is 2,000. 10% of any number is like one movement of the decimal place smaller. 10% of 24 is 2.4. Okay, it's a nice little thing to know that 10% of any number, it's basically a tenth of it. Just make it one move smaller, you just found 10%. Another example, percentage decrease. It's no different. It's just we're using the word decrease instead of increase. I don't have to put, I could put a minus in there and say, look, the increase is minus 25%. I'd rather say the decrease is 25%. So that's what we do. We just look at what was the change. Well, if the shirt went from 60 to 45, the change is clearly $15. The original price of the shirt was the 60, not the 45. So it's a 15 on 60 times 100. And there's one 15 there, there's 4 15s there, that's a quarter of 100, that's a 25% decrease. Okay. Finding a percentage of a quantity. Well, this happens a lot. I might be at a 20% off sale and I want to find how much I'm saving. And so it might be I want to buy this $80 thing in a 20% off sale, and so I want to find what is 20% of $80. Now I could use the tactic that I said before, that look, 10% of an item is just one move smaller. I know 10% of 80 is 8. So if 10% is 8, 20% is going to be 16. So that's a very valid way of doing it. But it's only when it's a nice percentage being asked. What's going to work all the time is what's written out here. Of we consider to be a times. Okay? You multiply, you don't divide, that's a common trap. No, 20% times $80 is what I'm trying to do. I know 20% is 20 on 100. So I can do that times 80. Well, it's a whole number, so it's an 80 on 1. And then I can cancel some stuff. Maybe that 0 and that 0 can go. What about that 0 and that 0? Top and bottom, that's cool. Now I've only got 1s on the bottom, 1 by 1 by 1 and all that. The top is 2 by 8, the bottom is 1. There's my answer. 16 on 1 is just $16. So I liked my other tactic better, but again, this method will always work. What if you don't like fractions? What if you preferred the decimal topic of last week? Well, then you'd say 20% is 0.2. So 20% of an item is the same as times it by 0.2. So if I want to find 0.2 of $80, then we use the tactic from decimals. We say, well, let's ignore the decimal places and just call it 2 times $80. Well, that's 160. But how many decimal places are in the question? There was 1. So there'll be 1 in the answer. So the answer is $16. So you can do with decimals or fractions. It's whatever you want. What about this one down here? That's not a nice percentage, 3 3/4. I'd play with that first, as I have done here. I don't want to, try and time something by 3 3/4 over 100. I'd rather do what I've done here. Let's just look at it again. Now, Look, I've done all that correctly, but I've done it in fractions. You can see I've gone 3 3/4. I've gone improper. 3 4s are 12 plus 3 is 15. That was our method. We had the same denominator. So 3 3/4 is 15 on 4. That's 15 on 4 divided by 100, which I've rewritten. It's 100 on 1, which is the same as 15 on 4 times 1 on 100, invert and multiply. So I got 15 on 400. And then I could have simplified it down. What if I wanted to work as a decimal? To be honest, I'd rather do it as a decimal. 3 3/4 is the same percent is the same as 3.75%, because I know 3/4 is a 0.75. If in doubt, just say what is 3 divided by 4. 4s into 3 doesn't happen. 4s into 30, well 4 7s are 28, remainder 2, and 4s into 20 is 5. Yeah, you bet. 3/4 and 0.75 are the same thing. So 3.75% is 3.75 over 100, and I know that 3.75 over 100, if I still want to play in decimals, is 2 moves smaller, is 0.0375. So instead of, I can still do it this way, and I'll admit to you, I prefer working in fractions because all this cancellation happens. Love it. But if I want to work in decimals, my question has become, what is 0.0375 of 2000? Alright, well, decimals say let's ignore the decimal places and do it. If I ignored the decimal places and did it, it would actually be 2000 times 375. So it's a complicated one, but let's ignore the 3 zeros for the moment. So what's 2 times 375? I keep forgetting, we've got the calculator. I don't think it hurts to have me talk about doing it without a calculator. But 2 times 375 will be 750. So there's my 750, and there's the 3 zeros. But how many decimal places are in the question? There were 4. So my answer should have 4. So there's my answer, 75. So you've got a fraction method and a decimal method. Again, I'm over with fraction. The unitary method. Love the unitary method. And really the unitary method is something I used on the slide before. I said that, what was it I was asking about, a 20% off sale. I knew that the full item cost $80. I made up a price tag and I said, look, it's $80 price tag, I want 20% off at this sale. What's that going to be worth to me? So I knew the full price, 100%, was $80. And I knew that 10% was easy to calculate, which was $8. And I said, hence, well, times by 2, 20% will be $16. Really, it was very similar to this unitary method. Unitary method is where you know something, you can bring it down as long as you're doing the same to both sides. Here I was dividing by 10. And I can still do the same to both sides. Here I'm timesing by 2. So let's look at how this logical approach, well, can be referred to as a unitary method. The first question here says, if 7% of amount is 56, so there's the information we're given, 7% of amount is 56. Find the total amount. Well, the total amount means 100%. You know, 100% means the whole thing. So if 7% is worth 56, whatever this thing is, just a number, I know that unitary method refers to going via 1. So if 7% is this, I can divide both sides by 7 and find out what 1% of it is. So 7 divided by 7 is 1, 56 divided by 7 is 8. So if 1% is worth 8, well, getting to 100 is easy, times by 100 on both sides. The full amount must have been 800. Let's confirm my answer. What is 800 times 7%? Well, let's convert fractions. Let's lose 2 zeros off the bottom and 2 zeros off the top. It's a 56 on 1. Yep, I was correct. The next one says 72% of a number is 360. Fine. 72% is worth 360. Hence, let's always just divide by 72 to get down to 1, the unitary method. But if you're going to divide the left by 72, you've got to divide the right by 72. And then to get from 1 to 100, you times by 100. To get from 5 to 500, yeah, we times by 100. Great, the original number was 500. Again, let's check that 72% times the number which we believe to be 500 is 360. Well, Again, I've lost 2 zeros already. The bottom just says 1 by 1, and 72 times 5 is 360. Yeah, all good. If 15% of an amount is 180, find half the amount. It's a pretty minor twist. We're told that 15% is 180, hence divide by 15 on both sides. 1% is 12. We'd only want to get to 50 this time, so instead of times it by 100, we times by 50. Hence half of the amount is 600. Now here is where I refer more like this one that I did up here. The unitary method does refer to going down to 1%, and since we've all got calculators, it's not a hard thing to do. Dividing by 72 I wouldn't want to do without a calc, but I don't care with a calc. But note that sometimes, like here, if 40% of an amount is 300, yeah, sure, I can divide both sides by 40, but if I'm looking for a quick way to do it, it's easy to get 40 down to 20, and it's easy to get 20 up to 100. So it's still called the unitary method, but technically we're not bringing it down to units. I just brought it down to something else. So all I did was halve both sides. If 40 was 300, 20 would be 150, and times 20 by 5 will get me to the full amount, times 150 by 5. So there's a shortcut there if you just see it and it looks easier, and maybe you don't have a calculator, whatever. It's nice to know that that method's there as well. Page down. So those unitary problem methods is what we do with original value problems. In terms of percentage problems, original value are the hardest, but if this unitary method works for you, then they're nice. Like, let's go to this question, and I'll do my working over here. If I purchased a frog, you know, that's what you'd do. If I purchased a frog during a 20% off sale for $4.60, what was the original price of the frog? Now the big mistake here is finding 20% of $4.60. But hang on, I was going to try and draw a frog then. I changed my mind. But the frog had a price tag on it. The price tag wasn't $4.60. Someone didn't walk up to a $4.60 price tag and calculate 20% of it. They walked up to some higher price tag, calculated 20% of it, and the answer was $4.60. So finding 20% of the new price tag, no, that's not what we want to do. We want to think about 20% of the old price tag. So the way to think here is that I want to know the full price of the frog, pre-sale. What was its price tag? I want to find 100%. And I've got to think, well, if it's a 20% off sale, what percent of his cost did I pay? I only paid 80%. Instead of paying 100, I took 20% off, though they did. I only paid 80% of the cost. And 80% of the cost, that was $4.60. And I want to know what 100% of the cost used to be. So this is now the line of data we got. The question doesn't say 80%, but we've got to think, what's a 20% reduction from 100? It's 80. How do I get from 80 to 100? Well, if I've got my calc, I do exactly what it says there. I'll just take it down to 1% by dividing both sides by 80, and pretends to use it. 460 divided by 80 is 0.06. I could have converted that to cents, but I'm fine with working in dollars. I know it's small, but it's okay. I know it's really 6 cents. Times by 100, yoink, yoink, $6. So the frog was originally $6. Now, my natural thing there wouldn't have been to convert to 1. It would have been this. 80 divided by 4 gives 20. 480 divided by 4 is $1.20. And then times by 5 got me to 100, and $5.20 is $6. Of course it's the same thing, it's just here's with calc and here's me with no calc, or just wanting to show off to the girl that's copying off me. Example B, it's a very subtle difference. This electricity bill, well, it increased, it didn't decrease, so I didn't pay less than 100% of its cost. I didn't even get to pay 100% of its cost. I had to pay 104%. The original cost of the bill was going to be 100%, but they upped it. So I had to pay 104% of the original value of my bill. And the dollars that cost me was $234. So I want to convert 104 into 100. And again, well, I'll admit here, I don't even have a pretty way to do this without my calculator. Okay, it's not a pretty question. I'm just going to drag it down to 1%. And I'm going to do that by, I know that any number divided by itself will get me down to 1. If I'm going to divide the left by 104, I've got to divide the right by 104. and as I've noted here, it gave me $2.25. And then to get from 1 to 100, I know that all I've got to do is times by 100. That'll tell me what the original value would have been. 225 times 100 is 2 moves, $225. So it went from 225 to 34 to 234. So it's only a 4% increase. Again, I could check what's 4% of 225, and sure enough, you can see it's going to be $9. I had a $9 increase. Okay. Page down. Oh, that week's a lot nicer than the fraction week. Okay. Where's the decimals week? We done? Yeah, fractions are 3, decimals are 4. This is 5. Okay, so in the questions, well, complete the table. So just remember, fraction and decimal mates here, and either times by 100 gets to percentage. So should I grab one? No, I'll make up an extra one. Say in this table was, I'll just replace this with something else so we can play with it. Say it was, what should I go for? 5th, 6th, 7th, 8th. Say I had 3 8ths. Yep, okay, that's good enough to play with. And they said, okay, convert that fraction to a decimal and a percentage. Now, fraction to decimal, that really was last week's stuff. That was just getting the number 3 and dividing it by 8. I might need some zeros here. 8s out of a 3. I don't think I can get 8s out of a 3. 8s out of a 30. Well, 3 8s are 24, 4 8s are 32. I can't get 32 out of 30. I've gone too far. 3 8s is 24, which leaves me a 6. 8s out of a 60, the best I can do there is 7 8s of 56 with 4 left over. And 8s out of a 40, well, that's 5. And that's on the dot, so I've stopped. So 3 8s is 0.375. And that, by doing that, I'm really not writing neat today, times 100 becomes a percentage, so it becomes 37.5%. Note that if I wanted to go straight from a fraction to a percentage, I still could have done it. I would have just had to have said 3 8ths times 100. Well, that's what I need to know. I would have looked for some simplifications. It's not going to be heaps. I can halve you and halve you. You're both still even. I can halve you and halve you. That's as good as I can get. 3 25s is on the top and 2 times 1's on the bottom. I've still got to work out what's 75 on 2. Alright, what's 75 on 2? 2's into 7 goes 3 times with 1 left over. 2's into 15. Sorry, I should put some zeros there. 2's into 15, 2 7's is 14 with a remainder 1. And 2's into 10 goes 5. I still got there. Okay, so I could have gone straight from fraction to percent, but if I'm being asked to go from fraction to decimal, that's a pretty nice short division, and then all I've got to do is give it 2 moves of the decimal place. We've got percentage change. Remember, it's just comparing whatever you're discussing over the total. Make sure the units are the same. Looks like I've got nothing sly in there, but if someone said, like, what percent is, say, pouring a 250ml cup of Coke from a 1.25 litre bottle. I'm comparing 250 mils to 1.25 litres. Just make sure the units are the same. Call it 250 mils over 1250 mils, because that's what 1.25 litres is. Once you've got the same units, you don't need them, as long as you're comparing like terms. And there I could say, well, let's lose a 0, there's 125 there, there's 5 25s there. So it's a fraction. I just poured out a fifth of the bottle. But if I say times by 100, I know a fifth of 100 is 20%. Percentage of quantity, again, just make sure that doesn't matter, that's just finding a percent times, remember of is times. The unitary method, well, we just did a good bit of that and some mixed stuff, just to have you wondering, is this finding the original value or the new value? Anyway, have a play, and I hope that helped. Okay, see ya.